On this episode of Newt's World, as many of you know, I am a dinosaur enthusiast. I have loved studying dinosaurs, reading about them, visiting museums since I was a young boy. So I was struck this week when an article in the New York Times entitled, "What's in a Name? The Battle of Baby T-Rex and Nanotyrannus," profiling a $20 million dinosaur fossil for sale to David Aaron Gallery in London. It seems there's a controversy about this, quote, rare juvenile Tyrannosaurus rex skeleton. My guest today is somebody you've heard before, who's done several podcasts with us, who's, I think, one of the most brilliant explainers of paleontology alive today. He is, quote, one of the stars of modern paleontology, according to National Geographic. He's worked on dig sites and in labs all around the world. He was also the paleontology advisor to the film Jurassic World Dominion. So you can imagine how pleased I am to welcome back my guest, Dr. Stephen Brusatte, Chair of Paleontology and Evolution in the School of Geosciences at the University of Edinburgh in Scotland. Steve, welcome back, and thank you for joining me again on Newt's World. A number of years back, my wife Callista had gotten me a copy of a Nanotyrannus skull from the Cleveland Museum, which sits proudly in our library. So I have a big interest in Nanotyrannuses. I do not have a T-Rex, of course, but I wouldn't mind having one if I could figure out where I'd put it.
Well, Mr. Speaker, it's always a pleasure because when we get together and talk dinosaurs, it's just a couple of guys that love fossils, love science, having chats about these things. And you've always been very kind to me for the books I've written and to the field of paleontology in general. You've been an enthusiast.
I have to ask you, have you ever been interviewed before by somebody who had a Nanotyrannus skull?
Ooh, I've been asked a lot of interview questions before. That's a question I've never been asked, so I don't know.
Literally, when you walk in our house, to your right, there's a Nanotyrannus skull sitting there. It's beautiful. It's a fabulous skull. It's a cast, of course, but we got it from the Cleveland Museum of Science, which has a terrific collection, particularly of fossil fish.
And that's the classic skull of this dinosaur. Maybe it's Nanotyrannus, its own species. Maybe it's a juvenile, a teenage T-Rex. There's a lot of debate about that. But that skull, which was found many, many decades ago and went to the Cleveland Museum, that's really the keystone of this whole debate. And it's a beautiful, beautiful, beautiful fossil. So you're very lucky.
It's either the type fossil of a new species or it's just a baby Tyrannosaurus rex.
Yes, it is. And I think either of those is very exciting. Either it's a distinct species of a smaller tyrannosaur. This animal would have been about the size of an SUV, more or less, whereas T-Rex as an adult would have been the size of a bus. So it's either its own species of smaller Tyrannosaurus or it's a teenage T-Rex, which is pretty neat because fossils of really all dinosaurs are very rare, and it's hard to have fossils of babies and teenagers and adults. So if we have a teenage T-Rex, that can tell us a lot about how this great, enormous king of dinosaurs grew up. So I think either way, this debate is resolved down the line. It's a very interesting and important fossil.
So I'm curious because I'm guessing that to be called a juvenile T-Rex, as it's listed at the David Aaron Gallery, it must be substantially bigger than a Nanotyrannus.
It's really hard to know. So there is this new specimen, this new fossil that's for sale. I don't know a huge amount about it. I know not much more than's been reported in the press, including in this New York Times article. I haven't seen this fossil myself. I haven't studied it. I've just seen some photos. They are marketing it as a juvenile T-Rex, but other people, other scientists would look at that same fossil and say, we actually think that's a Nanotyrannus, a separate species. So really, it's the same thing as your Cleveland skull, the cast of the skull that you have at home. Is it a separate species? Is it a juvenile T-Rex? We don't really know. We just know that it is a tyrannosaur of some type that's about the size of an SUV. It lived at the end of the Cretaceous period about 66 million years ago. And I do think until there are more fossils, scientists are going to be debating this for a long time because these dinosaurs are so rare.
I mean, even a Nanotyrannus as a predator would have been very formidable if you'd walked into him in the evening.
Oh, absolutely. T-Rex is the ultimate because this thing was 40 feet long. It weighed 7 or 8 tons. Its head was the size of a bathtub. It could crush us in its jaws. T-Rex is the ultimate. So if you compare any other dinosaur to T-Rex, it's going to seem maybe a little bit more lame. But come on, this Nanotyrannus or teenage T-Rex, whatever it is, was a big animal in its own right. It surely would have weighed about a ton. It could have run pretty fast. It could have chased you down, and it had a whole mouthful of sharp teeth. So you would not have wanted to come anywhere near this animal.
Do you think in market value it would make a difference in price if they concluded it was a Nanotyrannus? Or is it still so cool it would probably get the same price?
This is something that when the New York Times reporters were writing this article and they talked to me about it, they asked me this question. And it's a good question. When you're marketing something, this is something they're trying to sell for a lot of money. Of course, you're going to try to market that in the way that makes it most exciting for people and most exciting for, hopefully for museums that might want to purchase it. And I don't know, what sounds better to you? I'm not sure, really. Do you think a Nanotyrannus sounds better? Do you think selling it as a baby T-Rex sounds better? I don't honestly know. I think both of those things are quite interesting. And so you see auctions sometimes where these smaller tyrannosaurs are up for sale, and they call them Nanotyrannus. So you see both, and I don't honestly know which one would on its own fetch a higher price tag.
I was surprised to learn that in 2022, a Deinonychus, which was the inspiration for the velociraptors in Jurassic Park, sold for $12.4 million. I'm really surprised.
These dinosaur auctions and sales, yeah, they're happening with more frequency these days. It does seem like we're in a period of time where dinosaurs are in with the world of private collectors and art collectors and so on. There's just a trendy thing happening, and there's a lot of auctions. You hear of new auctions all the time or new sales. And it makes sense to me, right? I mean, I love dinosaurs, and there's something fascinating and enthralling about these animals. And so some of the price tags are getting pretty high. Some of them do surprise me when you're getting into the many millions of dollars. But I think it just shows that there is this enduring fascination with these animals. And there's a lot of people around the world that would love to have their own dinosaur. And I totally understand that.
Well, I noticed that there was a T-Rex named Stan who was sold at auction for $31.8 million in 2020. And he was bought by the Abu Dhabi Department of Culture and Tourism, I assume going into a museum. I mean, Abu Dhabi is really working at its tourism business. They have a relationship, for example, with the Louvre and have a sort of Middle Eastern Louvre building, which is pretty nice. But $31.8 million for a single skeleton is pretty darn impressive. I suspect encourages people to go out in the field, and particularly on private land, and try to find these things.
That number, when that fossil was sold, that 31 million number, that shocked me, and it shocked a lot of paleontologists. And it got us worried, frankly, because if a dinosaur goes for that much money, of course, other people are going to want to get in on the action. And it means that there's now a really high price, a bounty, if you will, on the dinosaur bones out there. So, of course, it encouraged a lot more people to look for dinosaurs. That's a great thing. But also, if the price tags go ever higher, it makes it less likely that museums can purchase these one-of-a-kind dinosaurs, more likely that they're only affordable to the ultra-rich, the really ultra-rich, the kind of people that have tens of millions sitting around. So I think it's a double-edged sword there. But thankfully, that fossil, Stan, that T-Rex, is going into a museum, as you say, in the Middle East. The museum's still being built. I'm very excited about that. I think it's a great thing. First of all, that fossil will be conserved and it'll be put on display. And it will also be put on display in a part of the world where there are not so many dinosaur fossils. So I think this will, in a way, be a great ambassador for both paleontology and American paleontology. T-Rex is an American dinosaur. So I think it's wonderful that children and families throughout the Middle East can go see this dinosaur in the museum down the line.
You know, I think prior to Stan, the most famous T-Rex purchase was by a public institution, the Field Museum of Natural History in Chicago, which bought Sue for about $8.36 million back in 1997, which today would be about $13.5 million, given inflation. I mean, I've been out there. It's really a very impressive exhibit. I mean, you can understand why some of the donors who support the museum thought that they would certainly be rewarded in popularity and in attendance by having Sue there.
Sue is my favorite dinosaur of all time. I grew up in northern Illinois. I'm from a little town called Ottawa. So hi, everybody out there from Ottawa who might be listening, about 75 miles southwest of Chicago. And Sue was purchased by the Field Museum when I was a young teenager, and I was incredibly excited. And then in the year 2000, it was put on display. And I was 16 years old then, and I remember very well, I tried to convince my parents to let me skip school that day to go see the opening of the exhibit, which was in the middle of the week for some reason. I think that was maybe just for journalists, I don't know, but I really wanted to weasel my way in there to see it. And they wouldn't let me do it. And, all props to my parents. They valued education more than anything. But we did go and see it very soon after. And I've seen Sue dozens of times over the years. It is, in many ways, I feel, my hometown dinosaur, and that fossil, probably more than any single fossil, really inspired me as I was studying paleontology. So I am thankful that that dinosaur, which when it was sold in the late 90s, that price was exorbitant. I am so thankful that a museum was able to work with donors and sponsors to get the funding to make sure that fossil was put on display, because there's an alternative universe out there where an oligarch buys that fossil and it disappears and is never put on display, and I never see it, and I'm never inspired, and millions of others in Chicago that have visited the museum are never inspired too. So my great hope is that when these one-of-a-kind dinosaurs are discovered, that some way or another they find their way to a museum.
Most of these do end up in some kind of a museum environment, but I think it was the number 3 guy at Microsoft personally owned 2 T-Rexes in his home.
If you have the Microsoft money, that'll do it. But you're referring to Nathan Myhrvold, who's very well known to us in the field of paleontology. I mean, he's a polymath, incredibly brilliant guy, and he has done research. He's done primary research. He's published academic papers on dinosaur fossils in peer-reviewed journals, the same ones that I publish in and other scientists do. So we greatly respect him in the field. And I think, as an aside, I'll just say that's one of the neat things about paleontology is, as a science, it is fascinating to people. It attracts a lot of different people that wouldn't necessarily be drawn to a lot of other sciences. So I think that is one of those things about dinosaurs, that enduring mystery and fascination that brings so many people together. And he's a great example of that.
Hi, this is Newt. If you live in California or you happen to be visiting, I'd like to invite you to my 2 upcoming book events in January. Callista and I are both going to be at the Richard Nixon Library and Museum in Yorba Linda on January 9th at 7 p.m. Tickets are available now at nixonfoundation.org. And Callista and I are both going to be at the Ronald Reagan Presidential Foundation and Institute in Simi Valley on January 10th at 5 p.m. Tickets are available now at reaganfoundation.org. I hope you'll join us for a book signing and a talk and a chance to get together and kick off the new year at the Nixon Library and the Reagan Library. I have to ask you just a little bit about not just Tyrannosaurus, but this entire group of dinosaurs who reoccur. I mean, there's sort of a parallel evolution over millions of years. And if you go back, 30, 40 million years, you get Allosaurus. There are a whole group of dinosaurs who end up very similar to T-Rex. That is, really big rear legs, really big, powerful head, and really tiny arms. And I'm curious, from your perspective, why do you think the tiny-armed giant predator keeps reemerging?
This is why I love talking to you, Mr. Speaker, about dinosaurs, because we can get in the weeds on these fascinating bits of science. And this is one of them. T-Rex is an incredible dinosaur, a sublime dinosaur in so many ways. But there were other meat-eating dinosaurs over time that also evolved to look something like T-Rex, to become around the size of a bus, to develop really big heads with lots of sharp teeth, and to make their arms smaller. as they did so. And as you say, the allosaurs are some of those dinosaurs. There's a group called the Carcharodontosaurs. I know that's a real tongue twister, but one of the most famous ones is Giganotosaurus, which was the villain in the new Jurassic World film from 2022, the one that I worked on. And there's many other examples. So there seems to be something about dinosaur evolution where time and time again, over and over again, these different groups of meat eaters all developed about the same size and similar types of bodies. So I think it means that there was something very successful about that design, about making a living, about hunting food, about getting enough food, at being able to get enough nutrition and cover enough area and so on with that type of body. And what it really is the head seems to get so big that it takes over most of the functions of the arms and the smaller ancestors. So in the smaller tyrannosaurs or smaller allosaurs, the ancestors of the big ones, the arms were longer and they had sharp claws and they were probably used to grab prey and to slash at prey. In the big ones, time and time again, the arms get small, the heads get big. The heads are probably doing almost everything. They're grabbing the food. They're biting the food. They're killing the prey. They're chopping up the prey. They're swallowing the prey. And that seems to be the case. But that's very different than, say, how mammals have evolved. Different types of meat-eating mammals, saber-toothed tigers, wolves, and dogs, and so on. They don't do that. And I think that speaks to just the differences of dinosaurs and mammals and the types of biology they have and physiology and so on. And there's so much more we could go into. The book I did, The Rise and Fall of the Dinosaurs, a few years back, I have a few chapters on these big theropod meat-eating dinosaurs because to me they're so fascinating. These are some of the most incredible animals I think that have ever lived in the history of the earth. Bus-sized predators with heads that we could fit inside that crushed the bones of their prey.
They're astonishing animals. And of course, they required other dinosaurs to have grown very big in order to be able to prey off of them. You can imagine how much these guys had to eat in order to sustain themselves, especially if, as some people think, they may have been warm-blooded, in which case they would have been burning up a lot more energy than, say, a crocodile does. And these were apparently obviously pretty good predators in terms of running, would have been very formidable. I mean, if they were appearing in Montana this week, it would definitely weaken the tourist attraction of going out in the woods by yourself.
You got it. I mean, these animals were feats of nature. The thing that really impresses me about them is not just their huge size. That's interesting enough, amazing enough. But one of the things we now know is that these dinosaurs, they didn't just have brawn, they had brains as well. We know they were quite smart. And the reason we know that is because we use CAT scanners to see inside of the skulls of dinosaurs. So maybe many of you listening, some of you at least, have had a CAT scan and you've gone in the tube and the x-rays of the scanner, allows the doctor to see inside of you without having to cut you open. And we can do the same with a T-Rex skull, a Velociraptor skull. And when we do that, we can see the brain cavity. We can build a digital model of the brain. We can measure the size of the brain, compare it to living animals. And that tells us that many dinosaurs were a lot smarter than we used to think. And T-Rex was probably one of the smartest dinosaurs of all. So it was a completely formidable predator with brawn and with brains.
I was at the Smithsonian one year, and they had borrowed the kind of CAT scan that automobile companies used. So they had this huge machine that they were putting fossils in, and it was fascinating to watch. But one of the points you make about the brain, you can actually tell how an animal is adapted based on its brain case. And my impression is that predators like T-Rex had remarkably good vision. I mean, is that your sense?
Yes, you're correct. You're absolutely correct. We can tell that both from looking at the brain through the CAT scans. We can see the regions of the brain that control the sense of vision, and those are fairly large. But what really tells us they had good vision is they had huge eye sockets. And in T-Rex in particular, the eyes faced partially forward. So they would have had 3D vision, stereoscopic vision, depth perception, just like we do. And that's actually a pretty unusual thing among animals. So it means they could have seen in 3D, they could have seen their prey, they could have seen their environment. That was one of their key hunting tools, surely. And we can also tell from their brain and from their ears that they had a really good sense of smell, really good sense of hearing. So these were predators that were well endowed with a whole toolkit of senses to seek out their prey.
Well, and that ability to have exquisitely effective eyesight, their descendants, the eagles and the hawks, have very similar patterns.
Yes, and that's a wonderful thing that although T-Rex is extinct and Triceratops and Brontosaurus and all of those classic dinosaurs, they've been dead for a long time, but the descendants of dinosaurs live on as birds. And we can study birds. We do study birds. We love birds. So many of us love going bird watching or have birds as pets. And through watching birds, appreciating birds, we can get a sense for what some dinosaurs were like. And birds are quite smart. Birds have great senses. Birds are active, energetic, dynamic, adaptable animals, and dinosaurs would have been like that too.
You were describing how a T-Rex would have grabbed its prey and would have torn pieces out of its prey, and was doing this with these very tiny arms that basically had no use. I was reminded that the one place I can think of that's parallel is watching a killer whale. That if you watch them, they take on a huge whale and they gradually devour it, and it's all done, of course, with their mouth. They have no limbs that enable them to operate. Very similar, I think, in a way to how T-Rex would have behaved.
Yeah, I think that's a very keen point and good observation. And sometimes, and I've done this before, I've called T-Rex like a giant land shark and kind of in the same way that these, whether it's big sharks, whether it's killer whales, when they're in the water, they don't really have arms or legs anymore, not proper ones. They have flippers to swim. And so they can't just grab prey the way that, say, a dog or a cat could. So they use their heads for everything. And I think that's what T-Rex would have been like. And it's a very unusual way of hunting. It's just different than any of the big predatory animals today. The biggest meat eater today on the land is a polar bear. Plenty ferocious. I mean, of course, we don't want to run into polar bears, but a polar bear could have been swatted away by the jaws of a T-Rex. So that just goes to show how much more extreme a T-Rex was compared to anything that's on land today.
Do you think the evolutionary advantage of the tiny arms was that since they weren't necessary, they just saved the energy of growing bigger arms? Some people have argued that if they hunted in packs, that smaller arms meant you didn't bite your neighbor as often.
There's a lot of ideas that have been proposed. We have a project that I'm part of that one of my former postdocs, a really brilliant young scientist named Greg Funston, is leading. And we're working this up into a paper as we speak, actually. We're talking about this even today over email. We're getting this ready. And we have some ideas for what the arms of T-Rex were for or what they were not for. I think the key thing is the arms are really small. The arms of a T-Rex are only the length of our arms, but they're much more muscular. They had huge muscles. We can tell that because muscles leave marks on the bones where they attach. So T-Rex was weird. It had arms that would have been the length of a human arm. So imagine a bus. These were the animals the size of a bus. So imagine a city bus with human arms sticking out of the front. How weird is that? That's really, really obscene almost. But those arms were so muscular that they were still doing something. If they were doing nothing, evolution would have got rid of them, just like the legs of a whale, for instance. The ancestors of whales had legs. They moved into the water. They didn't need them. Evolution got rid of them. So the arms of T-Rex were doing something. The muscles that are really strong on those arms were the ones that would have been used to grab onto things. So we think maybe they were using their arms to brace themselves when they were feeding or when they were mating.
When you go back to the forerunners of, for example, T-Rex or Allosaurus, do they tend to have much bigger arms?
They do, and that's what's really intriguing. The ancestors of T-Rex, the ancestors of Allosaurus, and the ancestors of some of these other types of dinosaurs that independently became big predators, in all cases, those ancestors were quite small. And the very first Tyrannosaurs, for instance, were only the size of dogs. And some were the size of humans, but that's it. And they were not only small, they had long legs, They could run really fast. They had smaller heads. They had more delicate, dainty teeth. They were still meat eaters, but their teeth were quite thin. And their arms were long. Their arms were much longer. Their arms had big, sharp claws at the end. So clearly these dinosaurs, which were not at the top of the food chain, these smaller ones would have been living in the shadows of other dinosaurs, but they were using their arms to do more things. And then over time, their descendants got bigger. Probably the arms became less useful, and the head took over most of those jobs that the arms once had, but the arms did not become useless. They were still doing something.
You're always so interesting. What are you working on and thinking about now?
The big thing now in the world of dinosaurs is that we have a major anniversary coming up, and that's 200th anniversary of dinosaurs. The very first dinosaur that ever got a name was Megalosaurus back in 1824, February of 1824 to be precise, in England. And it was the first time that scientists had recognized that there were these giant reptiles that used to live whose bones were fossilized and could be found. And a lot of these bones were found by workmen in quarries, digging canals, and so on during the Industrial Revolution in England, first of all, and then farther around the world. So that anniversary is coming up. It's amazing for me to think about everything that's happened over the past 200 years. 200 years ago, humans had no real concept that dinosaurs existed. Now dinosaurs are everywhere. We take them for granted. But we've learned so much during that time. And for me, we're working on this T-Rex project. That's one thing we're doing. We're doing a lot of work in my lab, not just on dinosaur evolution, but also on mammal evolution, how mammals took over from the dinosaurs. But one of the things we're turning our attention to is more about dinosaur intelligence and dinosaur senses and dinosaur cognition. Can we actually look at fossils and say more than just, oh, this dinosaur had a big brain? Can we actually get into the head of a dinosaur? Can we make comparisons to modern day animals that might tell us something about the types of brains dinosaurs had, how many neurons they had, the little powerhouse cells of the brain, what kind of behaviors they were capable of? Would they have recognized themselves in a mirror? Could they have navigated a maze? It sounds totally fanciful, but there's so much experimental work on the modern animals that are close relatives of dinosaurs, birds and crocodiles. And there's so much work now on CAT scans of dinosaur skulls that maybe we can bring these lines of evidence together. So I'm getting obsessed with that. I'm part of a team. It's a big international team. My good colleague, Larry Whitmer, a great dinosaur expert who you may know in Ohio, is a big part of this. And then we have colleagues in Sweden and the Czech Republic who are some of the world's experts on animal cognition and animal brains, Matthias Osvath and Pavel Niemiec, and we're all starting to work together, us and our students, about this. I have a new PhD student who's just starting, another student who will start next year, Adam Manning and Millie Mead here in Britain, and they're going to be working on dinosaur brains and dinosaur intelligence. I think that is so fascinating, and I can't wait to see what we find.
Will this lead to your third book?
Oh, the third book. Well, I did the dinosaur one a few years back, which again, thank you for the very kind review you did for Fox News of the rise and fall of the dinosaurs. I followed up with the one on mammals, the rise and reign of the mammals. That's the last time we spoke on the podcast, was all about mammals. And I do have a third in the works, and I'm just starting to write it. It'll be with the same publishers, and it's going to be about birds. So it's going to be about the origin of birds and the history of birds. The 150 million years of evolution that led to today's birds. Evolution that included routes of Earth history, penguins that were 8 feet tall, terror birds, elephant birds, birds with wingspans almost the size of fighter jets, all the way down to, tiny hummingbirds. All of this great, incredible diversity of birds today, over 10,000 species of living modern-day dinosaurs. Really, that's just the tip of the iceberg of what have been many more species of birds that have lived over time. Sometimes birds have been the top predators in their ecosystem. Other times, birds have adapted to do all kinds of remarkable things with their wings and with their feathers. And I'm just starting to dive into this. I'm starting to write it now this month. The new year is kind of my starting point here. And this will take me about 1.5 years to write. It'll come out probably in 2026, but keep your eyes tuned for that. And of course, I'd love to talk to you more about it when it comes out.
That would be fascinating. And it's interesting that when you look in the Paleocene and the Eocene, you could have imagined an alternative where the birds actually won out, because they were certainly remarkable competitors, and a number of carnivorous birds that were not somebody you'd want to run into in a dark alley.
No, and you're absolutely right. There were some ecosystems after the asteroid killed the dinosaurs. T-Rex was gone. That job at the top of the food chain was open, the top predator job. Mammals eventually filled those roles, saber-toothed tigers and dogs and cats and so on. But for a period of time in some ecosystems, it was birds that had survived the asteroid that got bigger and became the top predator. So in a way, dinosaurs kind of continued their rule at the top of the food chain in some ecosystems for many millions of years until mammals were able to catch up and finally take over. And I know that's going to be a big theme I'm going to explore in the book, because whenever I do public talks, whenever I talk to people, especially kids, and I say, what birds do you want me to really talk about in my book? And almost all the time I hear somebody say the big giant predator ones that lived after the dinosaurs died. So I look forward to writing about those.
That's what makes it the most fun. I've always been surprised when you talk about flight, for example, that I think 40% of all mammals are bats.
Yes.
So the competition for using the air is much more complex than people might know.
It is. And I think we don't appreciate that about bats just because most bats are nocturnal. We don't really see them. I mean, they're small, they hide away, they're mostly sleeping or inactive during the day, but there's tons of them and they live almost all over the world. And dinosaurs, though, and pterodactyls as well, the reptiles that lived during the time of dinosaurs, they evolved flight before bats. So dinosaurs had their time, continue today, of course, as birds. Bats are the newcomers on the scene. And really today, there's such a wealth of flying animals. We're in an almost unprecedented time in Earth history where there's such a great diversity of flying creatures.
Steve, I want to thank you for joining me, helping our listeners understand more about the dinosaurs and the auction world, and extraordinarily interesting issues that we're beginning to learn how to deal with. I loved reading both of your books, and of course your latest book, The Rise and Reign of the Mammals, is actually a superb book. And of course, a dinosaur person, how could I not love The Rise and Fall of the Dinosaurs? And I recommend both of them to everybody. And I think that having a childlike interest in the world that has been keeps you younger and keeps your brain open. And I appreciate you for being one of the great advocates of all of us understanding what's going on.
Well, thank you. That means a lot. And I appreciate you as well. You've done a lot for the field of paleontology. You've done a lot to keep this field in the public eye. Your interest, your enthusiasm, your work with museums, and the things you do, like, say, when you reviewed my book. These things all matter. So, a big thanks from me for your help with this field. And the last thing I'll just say is, any of you listening, if you're into dinosaurs as much as the speaker and I are, and you're ever confronted with this opportunity to purchase a dinosaur at an auction, think about donating that to a museum. That's one of the best ways to carry on a legacy in paleontology, to ensure that children, that families for generations to come can also become enthused about dinosaurs.
Thank you to my guest, Dr. Steve Brusatte. You can get a link to buy his latest book, The Rise and Reign of the Mammals, A New History from the Shadow of Dinosaurs to Us, on our show page at newtsworld.com. Newt's World is produced by Gingrich 360 and iHeartMedia. Our executive producer is Garnsey Sloan. Our researcher is Rachel Peterson. The artwork for the show was created by Steve Pendley. Special thanks to the team at Gingrich 360. If you've been enjoying Newt's World, I hope you'll go to Apple Podcast and both rate us with 5 stars and give us a review so others can learn what it's all about. Right now, listeners of Newt's World can sign up for my 3 free weekly columns at gingrich360.com/newsletter. I'm Newt Gingrich. This is Newt's World.